Good day everyone, and welcome back to DX Explorer for another video. I'm Yankee Oscar 6 Delta X-Ray Echo, and I'm back with part 2 of the mini whip antenna. In the last video we built the mini whip itself, and I promised that I'm going to be back with part 2 when we're going to build the bias T and we're going to make an antenna test, and that is what we're going to do today. Unfortunately, I'm not going to do a final antenna installation just because pretty soon I might have to change locations again. So we'll see about that, but I will install the antenna outside, and this way I'm going to be able to make a couple of antenna tests and see how it performs. Unfortunately, the enclosure for my bias T did not arrive, so I'm going to do a temporary setup for that one as well, just to be able to make this test and finish this video. And probably you'll see the photos of the finished bias T and mini whip antenna as well somewhere on social media, probably Instagram, because that's the only social media that I have for DX Explorer. Now, towards the end of the video, I might have some good news for those of you who are asking where are all the articles from the older DX Explorer blog, which is no longer available just because I don't have the time for it. And I might have some good news for you, yeah, stick around towards the end of the video. We'll talk about this a little bit later. Right now we're going to jump into building the bias T. Of course, I'm not going to continue without saying thank you to my friends at PCBWay for always supporting the DX Explorer channel. They have great PCB prototyping services, PCB assembly, SMD stencils, CNC, 3D printing, and a lot more services available for you. We'll also have to say happy anniversary, because this year PCBWay will have 11 years of unstoppable progress together with you. In the video description you'll find a link for this special event hosted by PCBWay. You will have available a lot of exclusive coupons, you have special discounts for the services they offer, and many other surprises. If you don't have an account for PCBWay, have a look in the video description. You'll find another link that you can use to register for your new account, and you will always get a discount on your first order. As I'm always saying, PCBWay is the way. Now, when it comes to building the bias T, it's pretty straightforward, very simple. If you take a look on the screen, you can see the schematic. It's very simple. You only have to deal with a handful of parts. And also there you can see the updated PCB board design. I'll explain in a little bit why I changed the older version. The one that I built right here in this video, it's actually the older version of the PCB board. And the reason for the update was simply to make it just a little bit smaller, and I wanted the switch and the power input on one side, together with the connector that goes to the antenna connector, just because I wanted all three of these on the back side of the bias T on the enclosure, and in the front side I just wanted to have the output for the receiver and the LED, and that's it. So that was the only reason why I modified the PCB board. Now, another thing that I wanted to talk about is the two capacitors, C2 and C3. The ones that I'm using in here are 100 nanofarad capacitors. The schematic recommends 560 nanofarads. I didn't have those, so I had to use this. These are actually filtering capacitors, so I don't think they should influence the antenna too much, since also the DC that I have, it's already filtered very well by the power supply that I have, so I don't have so much stress on that part. Now, on the other side, we have C4. With this one is a different story. Just like on the mini whip itself, if you want to have better performance on VLF, you'll need a bigger value over here. Now, if you use 560 nanofarads like is presented in the original schematic, I think it still should be fine. But since I didn't have those, I had to use this 1 microfarad tantal capacitor. But this one is polarized, so you have to be very careful about the way you solder this one. I'm going to talk in a little bit something about the mini whip antenna and some mistake I made in that video. that I had to correct afterwards. But the idea is that if you want to make sure that you're not mistaking, figure out first if you're doing the same like me, for example, and you're using a 1 microfarad tantal capacitor, make sure it has the proper voltage, because some of them, they work on really low voltages like 3 volts, 5 volts, and so on, and our circuit works on 12 volts, so they will blow up. I did that, don't ask me how I know. In the past, I didn't even know it was written on them about the power that they work on, and probably the ones that I used, the writing was actually erased, like I couldn't see much. And also I could not see that they are actually polarized, so I thought they are just like the ceramic capacitors, and that's how I ended up blowing them. But anyway, to make sure that you're not going to do the same like I did, finish the whole board except this capacitor, like, or whatever, any other capacitor where you're going to use the tantal capacitor, the polarized one. So you're going to install everything, and after that you power the board. In our case is this capacitor that we have to find out which is the polarization. Measure here the places where the capacitor comes with the voltmeter, and figure out which one is the positive, which one is the negative side, and then solder the capacitor accordingly, and you should be fine. In our case, with this board, I believe it should be the same with the updated version, but you have to double check. The lower side, where it's the the antenna connectors, on here we have the positive side of the capacitor, and on the top where you have the connections, the pins for the LED and the power input, in here you have the negative side. So yeah, I did made a mistake in the video when I was talking about the mini whip antenna, because the second capacitor actually soldered the wrong way, and I had to turn it around. You can see on the screen the correct way. I corrected that actually in a post. If you go on the community tab, you'll see there the updated schematic, but that's only if you use polarized capacitors like I did. Anyway, I'm done with this one, so let's make a quick test to make sure that it works fine, and after that it's time to put the antenna up, solder two connectors over here, two BNC connectors, and after that we can do a final test and see how the antenna performs. Okay, so in order to make this test, I'm going to power the whole thing. Actually, let me turn on the power on the other side. So let's measure over here. In this side, this is the antenna connection that goes to the radio, and this should not have any voltage. Oh, sorry. Let me put it on the voltmeter. So over here we don't have any voltage. That means that it works fine. We're not going to put any power into the receiver. And if we're testing this side over here, in here we should have 11.3 volts, and that's because I'm powering it with 12 volts, but I have a voltage drop because of the diode, so that means 11.3 volts. Probably since I'm powering the whole thing with 13.8 volts, I should have at this point something around 13 volts to say so. But because we're going to have losses through the cable, through the coax cable, especially if it's a little bit longer, probably somewhere at the point of the antenna input, we should have somewhere around 12 volts, maybe just a little bit under 12 volts, maybe around 11.5 volts, which is still fine. The antenna should work well. So yeah, it works, it doesn't smoke. It's time to solder the connectors, and let's make a quick test. And actually I have to go outside and actually install the antenna on the pole. So right now it's sometime next day, nearly sunset over here, and if you wonder why it took me so long to install an antenna and make a couple of tests, I think it's a good time to start talking about troubleshooting. In case your antenna doesn't work, don't ask me how I know. So let's talk about the JFET first. If you take a closer look at this one, I'm not using J310. Sorry, it's really tiny. I'm not using J310 just because I didn't have one. so I replaced it with a BF256B, and I knew about this when I installed the antenna, when I soldered all the components, but I forgot because I was in a rush to finish filming the video. And if we take a look here on the tester, you'll see something that didn't surprise me at all. Up on the screen you have the J310, the original transistor that is supposed to be installed in the antenna, and you realize that the drain and the source, the drain and the gate are different. So the drain is pin number 1 and the gate is pin number 3. On the J310 it's the other way around. So pin number 3 is the drain and pin number 1 is the gate. So of course it didn't work, and what I had to do was to install the transistor the other way around, the opposite way, 180 degrees, in order to fit the terminals. So no surprise there. This was my fault actually. Now I started testing the antenna, and of course it didn't work again. And I was wondering what else could be wrong, and what else could be wrong except the NPN transistor. So I had some transistor, same like the one required by the schematic, and this is it. Well, this one, actually the writing from the top, it's gone, because when I heated up the transistor to take it out, and I touched with my fingers because I was sweaty, the writing was gone. But if you take a look on the screen, the transistor is supposed to have this, you know, where you have this little wing on the side of the enclosure of the case, basically, of the transistor. This is supposed to be the emitter, and this one is supposed to be the collector. That's what I found in some data sheets that I searched for online, and also in various images, and also when I downloaded the footprint from online, that is also how it was set. So I soldered the transistor without checking, because I knew, you know, it is what it is. It should be fine. And another lesson learned, because look over here, the terminal number 2 is the base, number 1 is the collector, and number 3 is the emitter. So the emitter and the collector are actually the other way around. Now I'm not sure if different manufacturers have different ways of placing these pins, but technically this little wing is supposed to be on this side, if it was like what I had in the drawings. Well, anyway, I removed this one. I think I could still use this one if I soldered the transistor on this side, but I didn't bother doing that, so I replaced it with the same transistor that I used in the first version of the mini whip antenna, and that is the 2N2891. When I built the first mini whip, I used the same transistor, so I installed the same right now. Not sure if it's going to be as performant as the original transistor, but to be very honest, since this one doesn't fit the technical data sheet, I doubt that it's an original transistor, and I don't know, my opinion, could be a counterfeit. I have no idea. Probably you guys who have more experience with counterfeit parts, you might let me know. But yeah, it might vary. The pins might vary depending on the manufacturer, maybe. I have no idea. Anyway, long talk is not good, so let's start testing the antenna. I have here an entire collection of transistors that I might want to try to see which one will give me the best performance on the antenna. But that means I will have to take out this transistor and test many others. So I don't know if I'm going to do that, because I'm already bored And since I was happy with the way the first antenna worked with this transistor, I think I'm just going to leave it as it is. Anyway, you learned the lesson. Even for new parts, measure before soldering on the PCB board, and make sure the pins from the PCB board, the space on the PCB board, they fit the pins on the transistors. So yeah, lesson learned. Okay, let's install the antenna and do a couple of tests. Before installing the antenna outside, I thought it's a good idea to test the antenna while I'm inside, just so I don't have the same thing happening to me like last night, where I spent a couple of hours outside trying to install the mini whip on a high pole, and I think it was around 3 o'clock at night when I realized that, okay, it doesn't work, I have to take everything down. And I decided to do a measurement right now before I'm installing the antenna. So if we take a look at the Nano VNA, and if you remember, if you watched any of my older videos when I did the first mini whip antenna, Manhattan style, the measurements with this particular transistor, the NPN, they were nearly the same. Again, I'm not, because people thought that I'm measuring the impedance of the antenna. I'm not measuring the impedance of the antenna, I'm measuring the output impedance of the antenna, basically what we get from the output from the bias T. And I was just curious about the SWR, the way it is. So up around 30 megahertz, it's somewhere around 1 to 1 almost, and as we go lower, the SWR will rise. I don't know, maybe out of curiosity I might change the NPN transistor and test others to see which one will give me the best SWR output. Right now somewhere around 2.1 megahertz. Let's go here. Where's the highest SWR? Somewhere around 909 kilohertz. The SWR is somewhere around 2.7, nearly 3 to 1. So yeah, I don't know if it's worth playing around with the transistor to see if I can get better results, or just leave it like this. I don't know. Okay, tonight I'm just going to install the antenna, because since it's a temporary setup anyway, just to see if I can hear anything. And I have enough time when I'm going to do the final installation, probably after I'm going to change my location with the camper. Then I'll do a final installation, and by that time I will have enough free time to test different other transistors. So I'll just leave it like this for now. I apologize, I had to switch lights just because the main LED light is really noisy. Actually, the one that I'm using right now, it's a bit noisy as well, but not as much as that one. So I installed the antenna outside, and I want you to know one thing. It's only about 3 meters high, maybe not even 3 meters, 2 meters 80 centimeters, something like that, on a wooden pole. I have no grounding whatsoever set up for the antenna at this point. I do have a grounding, but I didn't ground it the antenna as it's recommended in the original article. But I wanted you to know, since it's just a temporary setup, how well it works without the recommended improvements. And here we are on the 40 meters band. It works fantastic, and I'm not going to waste your time doing this on camera, but I already did it. I've been swapping between the mini whip and the end-fed half-wave antenna that I have, and I honestly don't see much of a difference between both of them. So it performs about just about the same as the end-fed half-wave. fantastic. I love it. Let's go on the 20 meters band. Well, the 30 meters band actually, but I'm not going to digital stuff over here. Let's go on the on the 20 meters band. Let me change the step and let's see if we get anything over here. It's a bit quiet. Let's go on the SSB portion of the band. The 20 meters band was actually quiet on the end-fed half wave as well, so I might not be so lucky. Nope, it's quiet. I'm gonna try again probably later on tonight. Let me see on the 80 meters band if I receive anything. Nothing right now. Anyway, if it works on the 40 meters band, I'm pretty happy. Because I know the antenna works. And probably later on tonight, I'm not going to waste your time watching me doing that, but I'll play around with another receiver using the mini whip antenna. Yeah, we get some stuff over here as well. Not bad. Very nice. Lovely. Lovely, lovely, lovely. So it works and it's not even installed properly. Anyway, I'm going to stop here just so I'm not going to waste your time. Yeah, I'm going to stop the video, stop the test actually, and later on I will play around with I have an XH data receiver and I'm going to connect that one to this antenna, and I'll play around on medium waves, long waves, short waves, and so on, just because I'm curious about how well it performs even without the grounding. Okay, so I haven't showed you the way I installed the antenna just because it's really dark outside and it's really hot inside and I'm trying to finish this video fast. So it's important that you do a proper installation. Pay attention when you build the antenna, pay attention to details, don't make the mistakes that I did, make sure that it works fine. And once you install it, make sure you respect the instructions available in the download folder. You have the original article written by the author who designed the antenna, and you have some great recommendations over there. You'll get a really great receiving antenna. I think it will outperform the end-fed half wave, especially if it's properly installed. And not to talk about that it's multi-band, so you don't have to have wires spread around your house, you don't have to have magnetic loops that you have to adjust all the time. This one works perfect, even for SDR receivers or just for like an analog receiver like I do. Well, this was digital, but I have an analog one as well. So anyway, without getting the video too long, please read the instructions that you have in the original article over there, and I'm definitely sure that you'll be happy with this antenna. Now, talking about what I promised about the articles that I wrote on the DX Explorer blog long time ago, and I removed the blog articles and the blog itself. Gerhard from Germany, he will take over the dxexplorer.com domain, and he will build another blog over there similar to DX Explorer with interesting articles. So I would recommend you to keep going once he's going to be finished, and read the articles that he's writing on the hobby. His call sign, because I keep forgetting, is Delta Golf 6 Mike Charlie X-ray. So yeah, Gerhard will take care of the domain, and he will build another blog over there. What I'm going to do, like I said in the older videos, I'm going to transform all the articles that I used to have on the older blog in PDF files, like magazine article, and place those into the download folder from each project that has downloadable files available. I'm going to start doing that slowly very soon, and toward of the end of each year, I'm going to put all those articles in some little booklet, also PDF file, which will be available, basically a little book that will contain all the articles from that year. Well, in our case, from now in 2025, this book will contain all the articles of all the projects that I've been working on so far until 2025, including this year. So I hope you're happy with this solution. All the files will be available on the 28north.com website, which is my outdoor adventures and photography blog and website. So I'll try to build a secret link over there that you can visit. It's not going to be public. You will be able to see it if you access the link that you will find. The same link is going to be in all video descriptions from now on. Well, as soon as I'm done preparing this, but you have an idea for the future where to find this, and it will be a page that will contain all the projects that I worked on so far. So you don't have to go through all the videos and find the download link and so on. You will have them available over there. And yeah, I hope this will help you to find the project a lot easier. So yeah, the video is getting long. Enough for today. I'll see you very soon, probably on Monday, with another video. Until then, thanks so much for watching, and 73 from Yankee Oscar 6 Delta X-Ray Echo.